All right, here we go. For the love people, when you are doing your asymptotes, speaking of people stealing things of mine, not only did I have 30 calculators and now I have 6, I had about 8 highlighters, and now I have 2.
Oh, I got one from you.
Yeah, there's 2 right here.
Y'all are thieves.
No, I have one from you.
Okay. For the love, please draw your asymptote in a highlighter. Okay? Thank you. I don't think that people steal these intentionally. I think they accidentally throw it in their backpack when they're packing up and don't realize it. So I'm just asking you to check your backpack and see if that may have been you, that you can return something that's not yours. Okay? All right. So, please, 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 please put your asymptotes in highlighter. Okay? Let me zoom in a little bit. We have 2 graphs. Yeah? All right. What's my domain for each of them?
0. All the numbers.
Should be the easiest 2 points on the test. Yes? All right. In number 1, what is my H value?
0.
What is my K value?
5.
Which one represents where my asymptote goes? K. So if K is 5, my asymptote needs to be right there. Please do not draw your asymptote in pencil. It's very hard for me to read. Okay? Please come borrow one of my highlighters. Borrow and return to draw your 2 little asymptotes. Okay? All right. Let's see. So if K tells me where my asymptote is, H tells me what goes in the middle of my XY chart, correct?
Yep.
So I have 0 in the middle of my XY chart. I need to fill in some values around there. And yes, I do expect those 5 values in your XY chart. Capiche? Okay. So how do I find the corresponding Y values? Plug them in. So, -3, my calculator is going to work best if I don't use the times sign, but if I use the parentheses. Calculators just like parentheses for some reason. 2 to the, actually I don't think it matters. Let's use a times sign there. The exponent, however, does need to be in parentheses. And then plus 5. 4.25. Now I'm going to change that -2 to a -1. 3.5. Now I'm going to change that -1 to a 0. And I get 2. And a 1. -1. And 2. -7. So let's plot our points now. -2, 4.25. So that's going to be a little bit above the line of 4. -1, 3.5. That'll be halfway between 3 and 4. 0, 2. 1, -1. And 2, -7. All right. As I draw this, I need to be careful to not what?
Let it pass the touch or pass the asymptote.
Now, there are some people that just drew this. No. No. That's lazy. You need to show that it's going to continue on like this and draw your little arrow. Okay? I can't tell you how many times I get people that just zoom through things so fast to get the graph done that you're not careful with what you're graphing. I also got people that did this. Hang on, let me make sure my pencil works. They went like this. Actually, that's not bad. Let me fix that. They went like this. That's bad. Why?
Because it's a parabola.
That right there is an issue. It's not curving back down. So take a minute and draw in your graph carefully. Don't just scribble it in. As I would say with my son, don't just scribble scrabble. Okay? Be confident in your points. And make sure you're drawing a graph that reflects your confidence in your calculations. Okay? All right, so what is my asymptote? If you write this, that's not an asymptote, that's a number. The equation of this line is y equals 5. So your asymptote must be an equation. And since we're dealing with asymptotes that always are horizontal, your asymptote equation is always going to be y equals whatever k is. All right? What is my range here? Y is less than 5. Can it be less than or equal to? No, why not?
Because y can whatever you have, whatever dot you have, can never touch the line.
It can never equal 5 because that would be touching the asymptote. Okay? All right, number 2. What is my h value? What is my k value?
0.
So take the 2 seconds with a highlighter. Draw in that asymptote. Then you can put your highlighter away or return it if you borrowed it so that somebody else can use it. All right, so let's see. H is what goes in the middle of my XY chart. So I'm going to see a 1 right there. If you notice on the test that I graded, I did go through and I check each one of these points. There's little check marks next to it. I do check to see that all 5 points are there. So whoever's paper I graded, you should see those check marks on there. So expect that when I'm grading your individual test, I'll be putting those little check marks there too. I'm looking at every single point. All right? So I have to fill in values around 1, so that would be 0 and -1, and then 2 and 3. And I start plugging stuff in. This time I'm going to want to put the parentheses around my base because it is, what? A fraction. By the way, is this growth or decay? Technically it's neither, but it is what reflected? It's growth reflected because I have a b value of 2 and because it's getting away from the asymptote. This one is going to be decay. Why? 2/3 is less than 1. Not because it's a fraction, because it's less than 1. That's why it's decay.
Oh, let's go.
And that caught up a lot of people on a question at the bottom of this page. All right, so let's see. 2 parentheses, 2/3. Use decimals in your XY chart. There was one group that did fractions. I can't remember if it was this class or not, but please use decimals in your XY chart.
Why?
Because most people can understand where 3.5 is a lot easier than where 7/2 is.
Can you put it in fractions?
Please use decimals in your XY table. Everywhere else you can use fractions, but use decimals here, please. All right, 2 times 2/3 to the parentheses, -1 minus 1. And I get 4.5. Now I'm going to go change the -1 to a what? 0. And I get 3. Now a 1. And a 2. 1.3. And a 3. I get 0.89. I'm just going to call it 0.9. You only need to give me 1 digit. That's fine. Because for graphing, that's reasonable for accuracy. Let's see. -1, 4.5, 0, 3, 1, 2, 2, 1.3, and 3.9. So again, make sure that you are carefully drawing this in. And you're not just stopping right there, because your graph doesn't stop. And that you are not curving it back up in any way. And make sure you have your arrows on the end. Please draw a legit graph, not a scribble-scrabble. What is my range? Y is what?
Greater than 0.
Greater than 0. It's less than when it's below my asymptote. It's greater than when it's above my asymptote. And what's the equation of my asymptote? Y equals 0. Again, if you write just 0, I don't give you credit for the equation of your asymptote. Questions about those two? Is the XY table necessary?
Yes.
Yes. Okay? All right. Number 3. Write the equation of the exponential function shown. We need A, B, H, and K in order to write the equation. All right? So my B value is always going to be given to me. A value, I'm going to find the point that is closest to the asymptote. Which one is closest to the asymptote? The top one or the bottom one? The bottom one. So this is the point I'm going to be referring to. What are the coordinates of that point? 1, negative 2. Well, that 1 is what?
H.
My H value. Is negative 2 my K value?
No.
No, it's not HK, but it is H. What's my K value? The asymptote, which is what? Negative 4. And then the last thing I need to do is I need to identify A. Well, if my graph is above the asymptote, A is positive. If my graph is below the asymptote, A is negative. So what do I have going on here? So it is a positive A because it's above. Then how do I find my A value? I count the distance from the asymptote. So how far is that point away from the asymptote? 2. Then I just put it all together. 2, parentheses, 3. H is 1, so it's going to look like a minus 1 in my exponent. And then minus 4.
Wait, how did you get H again?
H is the x value of that point. Easy? Now, some of the other teachers have taught that if you want to verify that this is true, take the other point, which has coordinates of what? 2, 2? And when you plug in 2 here and 2 here, you should get a statement that's true. So 2 should equal 2 times 3 to the 2 minus 1. Oh, let me put some parentheses in there. Minus 4. And it does. So you can use that other point to check to make sure your answer is correct if you plug it in and you get a true statement. Now, this problem I didn't fix for you guys, but I fixed it for my other classes, but it probably didn't make a difference to you. This was supposed to be 1/3, and the only reason you would have known that it was an issue is if you had used that second point to check. Okay? So for you guys, I counted it correct if you had a B value of 1/2 just because I didn't get to check it with you guys first. But technically the value should be 1/3 for this. And that is because if you go plug in the second point, it doesn't work out unless you use 1/3 as your B value instead of 1/2. So again, A, B, H, and K. B is given. I'm going to go ahead and solve it with 1/3. Just pretend your 1/2 is a 1/3. Which point am I using as my H value or my center value? This guy right here, correct? And that's the point 2, 5. So which one of those is my H value? What's my K value? Which is? My asymptote. Let's see, is A going to be positive or negative? Why? Because it's under the asymptote, it's going to be negative. And then finally, to find A, I look at the distance between that point and the asymptote, which is a 1. So, I can write this as -1, parentheses, 1/3. H is 2, so it's going to look like x minus 2, and then plus 6. Or, if you didn't want to write the -1, you could have just a negative sign, but your 1/3 still needs to be in the parentheses, x minus 2 plus 6. So you could either have the negative sign like that, or I don't care if you write the -1 there. Capiche?
Yeah.
Okay, number 5. This is where we messed with you a little bit, intentionally. First off, don't worry about writing the word exponential on that little answer line. Just write growth, decay, or neither. Okay? I can figure out when you say growth that you mean exponential growth, because some people just wrote exponential, exponential. I'm like, well, okay, they're both exponential. Does it mean growth or decay? So just write growth or decay. What do I look at if I'm looking to determine if something is growth or decay? The B value. So if I look at the B value right here, that B value is 4. Yes?
Yes.
Is 4 growth or decay? Why is it growth? Because it's bigger than 1. Where's my B value here?
Oh, it's 0. Oh.
This one isn't even an exponential function. The only way you have an exponential function is if you have an x in the exponent. Do I have an x in the exponent?
No.
This is a 5th degree polynomial. It's not even exponential.
And there's no B value.
Which is why there's no B value. All right, letter C. What's my B value? 7/2. I don't know if people were looking at the 1/3 or if they just looked at the B value and thought fraction, therefore it's decay. But 7/2, is that bigger than 1 or less than 1? That's bigger than 1. So this is growth. Okay. So? Good answer. All right. Write an exponential equation to fit the data point, that and that. What is the equation of an exponential function? We're not worrying about h and k.
Y equals AB to the power of x.
Y equals AB to the x. No worries about h or about k. So I'm going to start off by plugging in this one right here. So I'm going to plug in 38.4 equals AB to the 2nd. You okay with that? What do I get when I plug in this one? 614.4 equals AB to the 4th. Now, in order to solve this, which one do I need to write on top?
614.
The bigger exponent one. So I actually need to reverse this. So I'm going to write 614.4 equals AB to the 4th. And then 38.4 equals AB squared. My A's are going to cancel. That's the easy part. And then let's see. 614.4 divided by gives me 16. And what happens with B to the 4th over B squared?
It becomes B squared.
Now when I square root these, I'm going to say B equals 4. Now, technically, yes, it could be positive or negative 4, and you could have 2 equations. Let's just go ahead and do the positive one for here, and just leave it like that. Okay? So, I have my B value. But if this is the equation I'm trying to find, how do I find the A value?
Plug it in.
Plug it back into one of the equations. I'm going to plug it into this one because that one's got smaller numbers. Yeah? So, 38.4 equals A times 4 squared. 38.4 equals 16A. Divide by 16.
2.4.
And A equals 38.4 divided by 16. And I get 2.4. So, I fill in my equation. Y equals A times B to the X. And there's my answer. Now, these ones turned out either to be a nice number or a decimal that was nice and reasonable there. If for some reason you have a long decimal, do you remember the rule for where you should round off for these problems?
3 numbers.
3 digits past the decimal. Okay. Questions there?
No, every day.
All right, let's look at the backside. Determine if it is exponential, quadratic, linear, or none of those. Show work to support your choice. No work, no credit. Okay? No work, no credit. Not even partial credit. No credit. Show work to support your answer. First thing I'm going to test in all of these is I'm going to test for linear. So let's see. To get from 32 to 16, you subtract 16, correct?
Yeah.
From 16 to 8, you subtract 8. 8 to 4, you subtract 4. And 4 to 2, you subtract 2. Is that linear?
No.
No. So I can actually cross off linear if I want to. Let's see. Should I go ahead and do all of them for linear first? Or should I just do one problem at a time?
I do one problem.
Okay. So now let's check quadratic. How do you get from negative 16 to negative 8? You add 8 to it. Question?
Yeah, instead of doing like 16, 8, 4, and 2, we should put divided by 2 probably.
We are adding and subtracting when we're looking for linear,
Okay.
not multiplying or dividing. Let's see. How do you get from negative 8 to negative 4? You add 4. How do you get from negative 4 to negative 2? Is it quadratic? No. That should always be your first check, is those two things. Next, if it's neither of those, I'm going to check for exponential. And we learned on the past side, the exponential equation is y equals ab to the x, correct? So, let's see. If I do y equals ab to the x, nope, not ready for an equation. I need to do 16 over 32. Remember, you have to do second over first. And then I want to see 8 over 16. And please do more than 2 fractions. Please set up all the fractions you possibly can so I can continue on. Please set up all those fractions. Don't just set up 1 or 2. 16 over 32 is 1/2, 1/2, 1/2, 1/2. This is the work that supports my conclusion that this is exponential. You can either write the e there or you can just circle it there. I don't care. Okay. Now, from the other side, I know the equation is y equals ab to the x. Yes? So, a is going to be whatever the y value is when x is 0. A lot of people put 32 in as a. That's not what it is when x equals 0. So if a is 16, what's my b value? 1/2 to the x. Okay? All right.
How is 16 your
Because it's whatever the y value is when x is 0. All right? All right, let's check for linear here. If I add those, how do I do that? Let's see. I add 37. This one I add 61. This one I add 90. Definitely not linear. How about this one? I add 24. And I add 29. Definitely not quadratic. Is 65 over 28 the same as 126 over 65, the same as 216 over 126? No, because these two fractions don't even reduce. So it can't be exponential, so what's my answer? Neither. Okay. All right, let's look here. From negative 5 to negative 3, you are doing what?
Add 2.
Add 2. Negative 3 to positive 3.
Add 6.
3 to 13.
Add
13 to 27.
14.
Okay, it's not linear because that's not constant. From 2 to 6.
4.
6 to 10.
Yeah.
10 to 14. We have a quadratic because I have the constant there. Do I need to write an equation for quadratic? No. Okay, here. 4 to 1.
Minus
A lot of people just put 3. Please don't put 3. You're not adding 3. You are subtracting 3. So put a minus 3. 1 to negative 2, you are also subtracting 3. 2 to negative 5, you are also subtracting 3. Negative 5 to negative 8, you are also subtracting 3. That's enough work to prove that it is what?
Linear.
Linear. So, linear equation is y equals mx plus b, correct?
Yes.
What is my m value?
That 3.
Negative 3. So I have y equals negative 3x. And then how do I find b?
0.
B is whatever you would get when x is 0. So in other words, I have to think backwards. What would the number be here before 4?
7.
Because 7 minus 3 is 4, right? That's the one that follows the pattern.
Yes.
So I need to put a plus 7 right there, and that's my equation. A lot of people mixed up their 7 and their 3. And a lot of people, because they didn't put minus 3 there, ended up with a positive 3 in their equation. Problemos. Okay? All right, word problems. I asked you to show me what you were plugging into your calculator, so let me tell you exactly what I mean by that. First off, these two problems right here, neither one of them say a thing about compounding, right?
Yeah.
Not a thing about compounding. As soon as it says compounded, 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 that's when you're using either the really ugly formula, the one that looks like this, A equals P times 1 plus R over N to the NT, that's your compounding, or if it says continuously, you're using your PERT formula. Which one says compounded continuously? 16 is the only one that says compounded continuously. So this one is going to be 35,500 e to the rate 0.0129 times 10.
Just reckon, is it only 0.125? It's 2 zeros, right?
I'm sorry, 0.129. You're right. When you plug that into your calculator, you get $128,963.92. So that's what I expect to see, the equation with the appropriate numbers in it and the answer. Okay, let me just verify the rounding there, 35,500. E to the, where'd my E to the? 0.129 times 10, 128,963.92. That 2 means my 2 stays at 2. Okay? So that means none of the other ones say compounded continuously, so I'm not going to use that formula again. These 3 are all going to use this formula. Yes? Yes?
Mm-hmm.
Okay. So I'm going to start up here. Compounded monthly. All right. A equals the principal, which is $450, times 1 plus, what's my rate? 0.012 over N.
12.
What is N? 12. Why is it 12? Because monthly, there's 12 months in a year. To the N, which is 12, times T. What's T?
6.
6 years.
72.
Go to your calculator. 450, and then 1 plus 0.012 divided by 12, close 2 sets of parentheses, to the parentheses 12 times 6, $483 and 577.
58.
Rounds that 7 to an 8, so I have 58 cents. Easy peasy? All right, same formula. 1,700 times 1 plus, what's my rate? 0.1 over 365 because it's compounded daily. If it was compounded quarterly, what would N be? 4. If it was compounded semi-annually, what would N be?
2.
2. If it was compounded weekly,
52.
52. Okay, make sure you're familiar with those. To the 365 times how many years?
30.
30. So again, 1700 parentheses 1 plus parentheses 0.1 divided by 365 close 2 parentheses to the parentheses 365 times 30. You need to know how to use your calculator at this point. Okay? Please do not be coming to me tomorrow on test day asking me how to plug these into your calculator. You've been practicing these, you need to know. Okay? Don't lose your calculator today or drop it on your way to class tomorrow and have to figure out a new calculator before the test. Because I don't have many to loan out.
That's tough.
Do you like how I keep dropping that in there?
Yeah.
So let's see. I get 34, 131.385 would round off to
39.
39. $1,700 became $34,000
Just under 30 years.
over 30 years. So you deposited less than $2,000 and end up with over $34,000. Not too shabby. Okay. This one is the same formula. However, there's a key phrase right here. Wants to end up with 20,000. So 20,000 is not my P value.
It's your A.
It's my A. So I have 20,000 equals P times 1 plus, my rate is what? 6%, so 0.06. Over N, we have compounded semi-annually, so N is
2.
to the 2 times what?
5.
So, what am I going to do? I'm going to plug in all this stuff right here. 1 plus parentheses 0.06 divided by 2, close 2 parentheses, to the parentheses 2 times 5. And I get this. Then I need to do 20,000 divided by this. Do I just hit divided by 20,000?
No, you hit answer.
No, I hit 20,000 divided by the previous answer. That's what I do. And I get 14881. So $14,881. And then what's my cents? 878. That 8 will make that 7 become an 8. So I have 88.
Wait,
Yes.
if it asks what's their initial deposit, that means you'd have to figure out the principal.
Yes, this is the principal. You deposit $14,881.88 now to end up with $20,000 in 5 years.
Okay.
Okay? All right, so if those are all the ones that use these formulas, what formula do these two use?
Oh, shoot.
I can't remember what the actual letters are. I should have looked that up. Let's see.
Checking the time.
I equals A times 1 plus or minus R to the T. By the way, did you notice I didn't give you any of these formulas?
Yeah.
Do you think I'm going to give them to you tomorrow?
Hell no.
Nope. So you got to know. So when do I use a plus? When something is increasing in value. I use a minus when something is decreasing in value. So in this first one, do we have increasing or decreasing?
Increase.
Increase. Another word for increase that you might see is appreciate if we're talking about money. Okay? So, y equals the original amount, just like your principal. The original amount is what? 85 children times 1 plus my R value. What's my R value? 15% would be
0.15.
to the T. What's my time?
25.
From 1995 to 2020 is 25 years. So, 85 times 1 plus 0.15. Notice it's not divided by n, and there's not an NT up there. Just saying. To 25. 2798.1. Now, we are talking about children, so please don't talk about 0.1 of a child. Okay? That's kind of morbid. We're just going to call this 2,798 children. And don't put a dollar sign there either. Please show me that you actually read the question.
Slavery.
I did have a group that put dollar signs. They must have done the other ones first and were just in a money frame of mind. But please note that that problem is not asking about money.
It's crazy.
Okay? All right. A new motorboat costs $9,000. The value of the boat decreases. Another word for decreases that you might see is depreciate. Opposite of appreciate. So let's see. 9,000. And then this time I'm doing 1 minus. What's my rate?
0.055.
0.055 to the T.
15.
I'm missing a 0, aren't I?
Yeah.
Yep, that would make a big difference. Nope, 9,000. Parentheses, 1 minus 0.055 to the 15th. 3852 point what? 295. Think of this as 29.5 would round up to 30. And yes, you need that 0 there because dollars and cents, you do need 2 digits past that decimal.
Yeah.
That one is talking about money. Now, should these answers be fairly reasonable? Yes. $9,000 decreasing in value. We're talking about 15 years. Yeah, that's reasonable. If your motorboat costs $9,000 and you end up with an answer of $18,000, that's a problem. It's not going to increase in value. Okay? Question?
Will you tell us how many places behind the decimal?
For money, it should be assumed that there's always 2 digits because that's your cents. Okay? And for children, we always want a whole number of children. Okay? Yes?
Can you go back to 9 and 10 so I can take a picture?
Yes. All right. Happy studying.
Miss Franken.